Welcome to this module. So in this module, we'll be looking at what MiniMax algorithm is. I'll be giving an explanation of how the algorithm works, and we'll also be looking at a pseudocode, which can be later converted into proper code. Okay, so let's get into it now. So what is a MiniMax algorithm? MiniMax algorithm is a popular algorithm used to create two-player games where one of the players is the computer, which is essentially the artificial intelligence. Okay, so we'll be using this algorithm. This algorithm is only used in games. Okay, so it's used in adversarial games where there's always a winner to create two-player games. Okay, so have you ever played games where you played against the computer? There was a very popular chess game. Do you remember? So the other player is the computer, and it's almost always impossible to win against these players. Isn't that right? There's also the solitaire game, and then there is the chess game, and so on and so forth, where you always play against the computer. So that's what the MiniMax algorithm helps you achieve. It helps you create a game where one of the players is the computer. So you can create one of those games that you see on your computers. Okay, so MiniMax, this algorithm is usually used in competitive zero-sum games and usually nothing else. So zero sum means when one of the player wins, the other player loses. There can't be two winners. So it's either one winner or there's a tie or a draw. So games like chess, tic-tac-toe, etc. are examples of games that come under these conditions. Okay? So one player wins, the other player loses. So that's what we are going to be creating with our MiniMax algorithm. The second condition needed to use the MiniMax algorithm is something called a fully observable environment. So the game should always show all the previous moves made by all the users and the current state of the game at every step of the way. Okay? For example, in chess, everything is out there on the board. Previous moves made by both the players are completely seen by both the players at all time. You know that, right? You must have played chess, or you must have looked at how chess works. So when one of them decides on which move to make next, they make a fully informed decision because everything is already there. They know where each of those chess pieces are. And so they know that if they make this particular move, they might win or they might lose, or they might lose the particular chess piece that they are making a move with, or they might lose another chess piece. So they know what's happening. So they're making a fully informed decision. So when they try to make a decision, they can look at all the possible next moves as well and decide which move is the best move for them so that they can win. This move might not necessarily make them win the game, but it's the best they can do at that time. So this is how humans play in adversarial games. Imagine an AI doing the same with the help of a MiniMax algorithm. So that's what we are trying to achieve here. So we're trying to simulate a human player who plays at an expert level. So this algorithm lets you see into the future. It lets the AI look into the final result of every possible move they can make for that particular turn. Then it'll tally the results of all the moves that it can possibly make and decide which of those moves will produce the most beneficial result for the AI, and it'll instruct the AI to go for that particular move. That is, it selects the optimal move. This is how we can make an unbeatable AI in a two-player adversarial game. Okay, in a two-player adversarial game with the MiniMax algorithm. It looks well into the future until the end of the game, in fact, so it always makes the right choice. This way, the only possible ending states of the game are either the AI winning or a draw. We'll be looking at how to create such an unbeatable AI for a tic-tac-toe game in this particular course. For now, let's just become thorough with what the MiniMax algorithm is and how it works. So I'll see you in the next lesson. Thank you.